So here we have a simple demonstrator of convection in a liquid. You can see here that we have a loop of water in a glass tube. Access port here, and you can see the water level. I've added some potassium permanganate to colour the water, and I've also added a Bunsen that has just been introduced here to heat at this location. So let's just have a look at what happens. So as the heat starts to warm this fluid, it starts to rise here. That causes fluid to move in this kind of pattern. So once water has risen here, other water has to move in and take its place, and that causes the whole loop to move in a clockwise direction. So why is this rising? Well, the water here is expanding. That's making it less dense than its neighbours, and so the less dense water rises through the more dense water. Other water then has to immediately come in and replace that, and you can see the potassium permanganate, the strong colour of it is starting to show up the movement of the water. And as this is being heated, the temperature sensor here is telling us that the water is gradually increasing in temperature. You can see it's up to nearly 33 degrees C there. So as time progresses then, you'll see more of the pinkness going around the loop, and that's water that has been round multiple times. The pinker it gets, the more times it has been round, and that's sort of a visual representation of what's happening with the thermometer, that the temperature of this water is gradually increasing, and so the pinker it gets, the warmer it gets, because the more times it has been round the loop. So if we continue to watch this, we'll notice some other things here. Firstly, you need to think about the fact that this process is being driven by expansion. So you may notice that the liquid level over here, as the experiment progresses, is gradually rising. And if you compare the very start value with the end value, and we'll maybe do that shortly, you should see that that level is much higher at the end of the experiment than it was at the beginning. So you can see now the water becoming much pinker, and this level here, hopefully you can see that this level here is actually getting slightly higher as the temperature here increases. So the pinker it is, that's an indication of how many times the water's been round, and so it's also an indication of how much opportunity the Bunsen has had to warm that water. You can see it's quite strongly pink now as we get to the end of the experiment. And obviously you wouldn't heat this forever because it'll eventually boil and that could cause problems. So you just heat it until it reaches a reasonable temperature, and you can see at the minute it's approaching about 50 degrees C, so that's probably enough heating. So hopefully this has been helpful in explaining what's going on in convection in fluids, because we've done it here for liquids, but it's just as applicable to gases. So remember, gases and liquids can be put together into the term fluids, meaning materials that can flow. So this is true for any fluid. Anything that has the ability to flow will have this behavior, where expansion near the heat source causes the fluid to rise, and then it will move round. And in any kind of convection diagram that you're drawing, you should always start where the heat source is. So you're always starting here and thinking about the fluid rising at that point. Usually then it's quite easy to figure out what will happen with the convection current itself. Okay, thanks for watching.